So my exponent rules. Maybe when we talk about them, they'll come back to you. The first one is the product rule. What's a product? The result of multiplication. If I have 3 squared times 3 to the 4th, the product, right, I'm multiplying. I know I need to use the product rule. The product rule tells me I need to add my exponents together. So my like bases, which are both a big old 3, they fuse together to a single 3 and make 3 to the power of what? 6. Why can I do that? If I expand out 3 squared, that's 3 times 3. 3 to the 4th is 3 times 3 times 3 times 3. How many 3's do I have in total now?
6.
That's just 3 to the 6th, isn't it?
Yeah.
So in order to avoid doing all that expanding, I can just add those exponents together. That's the product rule. Give me a thumbs up if that makes sense. Perfect. What's the opposite of a product? A divide. That's right. A divide. The answer to a division problem, as we all know. Quotient rule. Okay, the quotient rule tells me if I have like bases that are being divided, my like bases fuse into a single base, and what should I do with my exponents? Subtract. Obviously, the opposite of a product is a quotient, so the opposite of adding my exponents is subtracting them. What's 5 minus 2? 3. Well, why can I do this one? If I expand this out, 4 times 4 times 4 times 4 times 4 over 4 times 4, is there any factors in common I can circle up and cross out? Yeah, how many pairs of 4s? 2. 1 pair, 2 pair. How many 4s are left? Well, that's just 4 to the 3rd. So again, in order to avoid doing all that expanding, I can just subtract downward. That's the important thing. I'm not subtracting 2 minus 5. I'm going top down, 5 minus 2. Does that sound good? Yeah? Third rule, power rule. Everybody say power rule.
Power rule.
So the power rule is when I have too much power. Let's say I've got 5 squared to the power of 3. So I've got a power that's raised to another power. Everybody see that?
Yeah.
What do you think we should do with our exponents now?
Multiply them.
Multiply them. 5 to the power of 2 times 3 is 5 to the power of what? 6. Well, why can't I do this one? Let's expand this out. 5 squared to the 3rd power is 5 squared times 5 squared times 5 squared. Everyone agree with that?
Yeah.
Well, what's 5 squared? That's 5 times 5, 5 times 5, 5 times 5. How many 5s do I have in total? 6 of them. That's just 5 to the 6th. Once again, in order to avoid doing all this expanding work, we can just multiply those exponents together. Everybody see that?
Yeah.
All right. So those are the 3 big rules. Then we add in product bases and blah, blah, blah. We're not going to worry about that, okay? So if I look at number 1, it's saying 3 to the 5th times 3 to the blank equals 3 to the 8th. Well, if I'm going to do the product rule, I would add my exponents, I would add my exponents together. So 5 plus what is going to give me that new exponent of 8? 3. Give me a thumbs up if you got that right. N is equal to 3. Nice. Number 2, we can do this a couple ways. And I think it was it Aldrich that helped me with this one yesterday, right? It was the one that I got wrong. How many times larger is 2 times 10 to the 2nd versus 2 times 10 to the 8th? Well, what is 2 times 10 to the 2nd? 200. What is 2 times 10 to the 8th?
8 zeros. Wait.
Not 8 zeros.
7.
Oh, wait, it is 8 zeros. My bad. Yeah. You're right. It's 200 million, right?
Yeah.
If I get 200 people together and they each have $1 million, how much money do we have? If I have 200 people and they each have $1 million, how much money is that all together? 200 million, right? So 200 is 1,000,000 times larger than 200 million. Does that make sense?
Yeah.
Well, how can I write 1 million in scientific notation? 1 times 10 to the 6th.
Because there's 6 zeros.
Boom, that's option B. Another way we could have done this is with the quotient rule. 2 times 10 to the 8th over 2 times 10 to the 2nd. What's 2 divided by 2?
1.
1. And if I subtract 8 minus 2, what's my new power of 10? 6. Look at that. Same exact thing. Thank you, Aldrich. All right. Number 3, what's wrong with Adam? Well, what's wrong with Adam's problem? I don't know what's wrong with Adam. What's wrong with his problem? What step did he mess up on? Step 2. What did he do wrong in step 2? There should not be a denominator. You're right. Alex?
The denominator should be 1 instead.
Exactly.
Over 1 is just 6.
And if I have it over 1, I don't need it over anything, right? So instead of putting it over 1, they put it over 8 to the 1. That's not right. Because then they're just doing the product rule twice. We don't want that. All right? Over to number 5, just to keep it on the exponent vein here. All expressions equivalent to this. Ooh, gross. What do I want to do with this first? I'm going to add the exponents. I'm going to solve the parentheses first. What's negative 3 plus 4?
1.
1. What do I want to do with these exponents now?
Multiply.
Multiply. Should I leave a negative exponent in my answer?
No.
No. How can I make it positive?
By putting 1
Take
over
the circle.
Put it over 1, flip it around, make it positive.
So we 1 over 2.
1 over 2 squared is just 1/4. Can I move on?
No.
No, because it says to select all expressions, which means I got to go through them all and make sure that none of the other ones are also equal. 2 to the 6th times 2 to the negative 8th. If I add those together, I get 2 to the negative 2. That looks familiar. Where have I seen that before?
We just did it.
Oh, yeah, we just did it. So that one's equivalent as well. 2 to the negative 5th times 2 to the 2nd gives me 2 to the negative 3rd. Is that the same thing?
Nope.
Nope. Is 4 the same as 1/4?
No.
No. So just those first 2. All right. Number 8, again, this is the last exponent one. 4 to the power of x over 12 to the power of x equals 1/3. What can I put in there that's going to make this equation true? Alex, what do you think?
1.
1? Well, let's see. 4 to the 1 over 12 to the 1 equals 4 over 12. What can I divide the top and the bottom by? 4. Gives me 1/3. Hey, look at that. That worked out. X is equal to 1. Does 2 work?
No.
There's only one way to find out. 4 squared over 12 squared is,
60 over.
well, it's 4 times 4 over 3 times 4 times 3 times 4, isn't it?
Yeah.
What can I cancel from the top and the bottom? All the 4s. I'm left with 1 over 3 times 3, which is 1 over 9. Is that the same as 1/3? No. So that's not going to work. X is equal to 1. All right.